Assalamualaikum and hi to my lecturer Puan Nur Ain and all of the audience. We are from Group 12 of Engineering Mathematics 1 Section 1 and 2. Today we are going to present about the study case that we got for this group project. The title of this case study is a retention pond design. The scenario of this case is a construction project requires a retention pond to manage rainwater runoff. The length of pond is expands at a rate of 1.5 meter per hour as the project progresses. Engineers also observe that the water depth increase as rainfall continues. That we have to design the pond as a rectangular prism with fixed width of 10 meter. They have two sub-questions for this case that we will explain in the solution. The problem statement of this case study is to determine the effective rainwater management in construction project to mitigate risk of flooding and ensure sustainability development. This case study focuses on designing a rectangular prism-shaped retention pond to manage rainwater runoff. The unique challenge of this case study is when the length of the pond increases steadily at a rate of 1.5 meter per hour as the project progresses and the water depth rises due to continuous rainfall, increasing at a rate of 0.2 meters per hour. This study seeks to address the following problem to calculate rate of volume increase when the pond is 30 meter, ensuring the design and explore significance of understanding volume change in context of flood control and drainage system design.
Assalamualaikum, my name is Nick Irfan Shazwan bin Nixo, card metric AA220057. I will be presenting on the solution sub-question 1. If the water depth is increasing at a rate of 0.2 meters per hour, what is the rate of volume increase in the pond when its length is 30 meters? This problem involves calculating the rate at which the volume of water in the pond increases. The formula of the volume of a rectangular prism is V equals to L times W times H, where L is length, W is width, and H is depth. Since both L and H are changing over time, we take the derivative of V with respect to time t and get dV over dt. We assume width is at 10 meters. The problem states that the depth increased with a rate of 0.2 meters per hour while the length increased with a rate of 1.5 meters per hour. We also assume project started at t time equals to 0. We substitute the values to dV over dt and we get 16h plus 60. In order to get h, we use L where the rate is 1.5 meters per hour and assume it started at 0. So at 28 hours, the depth h becomes 4 meters. We substitute the values and we get 120 cubic meters per hour. In summary, this calculation shows us that the 20-hour mark, when the length of the pond is 30 meters and the depth is 4 meters, the volume of water in the pond is increasing at a rate of 120 cubic meters per hour. Thank you.
Solution. Sub-question 2. 1. Why is understanding the rate of volume change in a retention pond significant for flood control? First, preventing flooding. If the pond falls too fast during heavy rain, it can overflow and cause flooding in surrounding area. Second, building smarter drain system. This knowledge helps in designing drain system that can effectively handle the flow of water. Third, using water wisely. Retention ponds are not just for controlling flood, they can also store water for irrigation or help restore local ecosystem. 2. How might this information affect drain system design? Accurate prediction of water inflow and outflow rate are essential to ensure the retention pond work well with the overall drain structure.
Hi, Assalamualaikum and hello everyone. Today I am going to talk about conclusion and discussion about retention pond design. The design of a retention pond is a critical component of sustainable stormwater management. A well-designed retention pond effectively mitigates flooding, control peaks, runoff rates, and improve water quality by allowing sediment and pollutants to settle. Here are some key to discussion. Firstly, hydrological effectiveness. The pond must be sized appropriately to handle the peak stormwater volume based on site-specific rainfall data and runoff characteristics. It will ensuring sufficient storage capacity to crucial for managing heavy rainfall events and protecting downstream areas. Secondly, environment benefits. Retention ponds promote groundwater recharge and support biodiversity to enhance aesthetic value. They act as natural habitats for various aquatic and terrestrial species while improving the surrounding ecosystem. Thirdly, design considerations. The proper slope gradients, vegetation along the pond banks and sediment for beds are essential for functionality and long-term performance. Incorporating safety measures such as fencing or gradual slopes ensures public safety. Lastly, maintenance requirements. The regular inspection and removal of accumulated sediments, debris and invasive vegetation are necessary to maintain the pond's efficiency and longevity. In conclusion, the success of a retention pond design hinges on a balance between hydrological efficiency, environmental considerations, and practical implementation. By addressing this aspect, the retention pond serves as an effective and sustainable tool for managing the urban stormwater. That's all from me.